Hello, my name is Shalen, and I'm a team member here at Elemental Hardware Enrichment. Join me in this video as we inspire that creator in you.
Hello and welcome to Elemental Hardware Enrichment. In this video we're going to be showing you our spin top project and the machine that starts everything off, the CNC. This timeless toy is not just an enjoyable craft, but a hands-on exploration into the world of rotational motion, physics, and craftsmanship. The spin top starts off being made on the CNC, which is one of our biggest and most technical machines that we use here. The spin top is a great project to show students about rotational motion and physics. Spin tops were one of the first toys that humans invented. The first spin top dates back to almost 6,000 years ago. Although a lot has changed since the first spin tops were invented, the spin top remains a timeless pastime. Its simple design makes it an easy toy for anyone to pick up and enjoy. Our kits include every part and the hardware you need to create the finished spin top you see here. As you build, you'll learn to use sandpaper, tape measures, hammer, nails, and wood glue. The design and custom painting, however, are all up for your creativity, allowing you to make it truly your own. Like the other videos in this series, we will not talk about how to build the spin top, but if you are interested in how to build it, you can use the QR code here or follow the links in our description on this video to learn more. Just like most of our projects, the spin top begins life on the CNC. After the initial parts are made on the CNC, many different machines have a part in producing the spin top, from our handheld tools like the mini circular saw to our routers, drill presses, and table saws. Now let's take you behind the scenes and show you how it's made.
We have two CNC machines here at Elemental Hardware Enrichment. We use the Laguna SmartShop 2 Pro Series, which are the ones that I run and use on a daily basis. Now the CNCs are some of our more complicated machines because they involve programming and multiple things to watch over when running parts. But when running smoothly, they produce a high volume of parts with accurate dimensions over and over. Now there are all sizes of CNCs, from small home personal use to the industrial ones like we use, and bigger as well.
Now let's talk about the different parts that make up the CNC. Our Laguna CNC has an 8-tool capacity and is a 3-axis machine. There are both bigger and smaller CNCs that have more axes and tool holding capacity than this one. In industries like the aerospace industry, you will most of the time see the bigger CNCs that have more axes and cut materials like aluminum, stainless steel, and titanium. When we refer to tool or bit, we're usually referring to the part that holds the bits. Here's a breakdown of what holds the bit into place. The collet snaps into the nut, and the nut screws into the collet chuck. When the nut is tightened properly, it squeezes the collet and holds the bit into place. The 8-tool capacity allows us to change tools easily during a program and use a specialized bit to do several features. There are all sorts of types of bits and sizes, and without the tool changer, we would have to write, load, and change programs and tools multiple times, causing downtime in production. The 3 axes on this machine is X, Y, and Z. What this means is that the machine can move forward and backwards, which is the Y-axis, left and right, which is the X-axis, and up and down, which is the Z-axis. What moves the machine around is called a gantry. These axes allow us to use large wood sheets and different size thickness of material. To hold the material safely down while cutting, the CNC uses vacuum pumps to create suction on the table. Using a board made of material called MDF that allows air to flow through it, we can place a material to be cut on the surface and get a level surface that holds the material being cut. This board is commonly referred to as a spool board, and it also helps protect the CNC from being cut as well. Here you can see where the tools cut through the material and cut a little into the spool board, preventing the CNC table from any damage. When cutting the parts, the machine produces a lot of chips and dust that need to be removed while cutting. This is where a dust collection system comes into play. Think of this dust collector as a huge vacuum like the one you have at home. There's a cover with a brush that surrounds the CNC bit, and attached it has a hose that pulls the chips into a container where the chips can be removed and disposed of properly. Not only does this system keep the chips removed from the cutting area, but it helps keep the surrounding environment clean as well. Our project parts start here in VCarve. This program allows us to create a part with accurate dimensions and multiple types of bits that can create various shapes and designs. We first start out by telling the program what type of material we are cutting and the dimensions of that material. Next, we start by creating the profile of the part, for example a square, and tell the program what details are needed to create the square. Now let's just add a circle inside the square like one of our spin top parts have. Next, we tell the software what type of tool we want to use to cut the part out of the wood. The great thing about this software is that it can show you what the results are as if you were actually cutting on the CNC like this. When finished designing and programming the part, we save what is called a toolpath file and import it into our CNC control panel. After loading the program, we set up the CNC with the materials and tools that we want to use that were entered into the program. As you can see here on the CNC, it only cuts one side of the wood. Although we can flip the material and cut on the opposite side, we design our parts so that we only need to use one side of the material. Using other machines in our company, we can add things like a chamfer or drill. The spin tops also have dowels that need to be cut to size using our table saws. Our carpenters can quickly produce a lot of dowels using a table saw. Using a slide and guides to set the dimensions needed, they simply place the dowels against the guides and cut. After the dowels are cut, there are still holes to be drilled using our drill presses, and to help make all these holes the same for every part, we use what are called jigs to allow the operator to quickly place and accurately drill the holes into the dowels. After all the parts are produced, they then go through a quality control inspection to ensure every part meets our expectations and standards. And the final step before you touch the project is our packaging department, where they carefully put all the pieces together and send them off to be built by you. Some of the things we do to make sure our parts come out to our strict standards are simple things that you can do if you use a CNC as well. Keeping a sharp tool when cutting is one of the best ways to ensure that you get a good clean edge, but also helps produce good dimensions when cutting. A dull tool can cause a rough, out of dimension cut and could cause a fire as well when cutting on wood. Also, using the right tool for the job is just as important. It is not a good idea to use a small bit for doing something that can be done with a larger bit. It saves time using a bigger bit when possible, and also helps prevent excessive wear of a smaller bit as well. Cleaning and properly prepping the spool board before each job helps the new material hold the machine better and allows for a more accurate and safer cut of the material. A dirty machine can actually produce bad cuts by causing vibration and the material to lift or shift when cutting. For our personal protective equipment, or PPE, the most commonly used are glasses, earmuffs, and gloves. The CNC does create a lot of fine particles and wood chips when running, so wearing glasses help prevent these from getting into your eyes. Dust masks are important as well when cleaning, and especially when cleaning the dust collector. Gloves are a big help when handling the material on the CNC, both on the setup and removal of the product. After cutting materials like acrylic or metal, CNCs can create very sharp edges or slivers on the product that are removed or treated later in our production. Now, the most important PPE items to use on the CNC are earplugs or earmuffs. Everything combined when running on the CNC creates a full range of low to high pitched noises. A CNC bit can loudly squeal sometimes when cutting certain materials, creating a high pitched noise. The vacuum pumps and dust collector use large fans and motors to run and create mid to low range noises. Using ear protection helps prevent any long-term damage to your hearing. A lot of large machines have what are called e-stops or emergency stops. The e-stop for each of our machines is right here on our controllers. If anything goes wrong, this allows the operator to quickly stop everything on the machine and prevent any damage to anything or anyone. We have a lot of videos coming your way and cannot wait to share them with you. Make sure to like, subscribe, and hit that notification bell so you don't miss an episode. Thanks for watching, and I'll see you next time.